have to turn here for itself. So, can you see me, Anna? Yes. Okay. Okay, so okay. Good afternoon, everyone, and good afternoon to our online participants. And it gives me great pleasure today to introduce to you Hadley Wickham, someone who really needs no introduction. He is very well known for his R packages, tidyverse, dplyr, ggplot2, and many others. They've been very busy. I see frequent updates of new versions on LinkedIn. And Hadley is the chief scientist at Posit, which was formerly RStudio. And the work he's done has really fundamentally shaped the way we do data science today. So we are really looking forward to listening to your guide on the LLMs. Thank you very much.
Thank you. So before we get started, a few questions for you all. Like, how many of you use R currently? Okay, pretty much everyone. And how many of you use ChatGPT or Claude or Gemini or something like that? Okay. How many of you pay for it? Okay, cool. Okay, so I'll pass this around. I bought some stickers, so if you're an R user, take as many as you like to put on your laptop. Yeah. So what I want to talk to you all about today is basically some of my thoughts about how you can use LLMs kind of effectively as a data scientist from R. But before I get started, I want to kind of acknowledge that at best, you probably have deeply, if you're anything like me, you probably have deeply ambivalent feelings about LLMs. Like, I certainly feel like they kind of fundamentally attack my my identity as a data scientist, as a software engineer. And I feel like a lot of existential dread, basically, about like what are LLMs going to do to the things that I love spending my time doing. So basically, like, whatever you feel about LLMs, whether it's excitement or fear, I think is totally legitimate. If you are worried about them, however, I think the best thing you can do is engage with them. And that's what I have found most helpful at really trying to get my head around what's happening with them. And so my goals today are to give you a few useful skills and to demystify some of the walls of jargon that surround LLMs. And so to get started, I'm going to be doing this using Alma, which is the R package that I wrote to interact with LLMs from R. So this is what using Alma looks like. Even if you've never used R before, this shouldn't be too complicated, hopefully. I'm going to load the Alma package, and I'm going to start a chat in this place with Claude, because Claude is my favorite LLM, not least because it does a pretty good job of writing R code. And so I'm going to ask it a simple question. Just going to interact with it with like many R objects. This is an R6 object, so I'm going to use a $ to call the chat method, and it's going to print some results back. I think one of the reasons that LLMs are kind of hard to grapple with is that they kind of turn upside down the things that we think of computers being good at and things of computers being bad at. So for example, we kind of traditionally think, let me just hide this menu. Hide this. No, I just showed the thing I wanted to. Okay, sorry. Okay, so we think of computers traditionally being really good at multiplying two large numbers together. So what happens if we create two large numbers and ask Claude to multiply them together? Well, it's going to very confidently give me an answer, and that answer is wrong. It's not like totally wrong. I guess it gets the first 4 digits correct, but you probably like your computer to be a little bit more accurate than that. Another thing we think of computers as being pretty good at is counting. We could ask Claude how many N's are in the word unconventional. It might take you a little while to count exactly how many there are, but I think you could convince yourself that there are more than 2. And kind of concerningly, if I ask an LLM to do this a few times, I get back different answers. Sometimes it says 3, and sometimes it says 1, which is clearly incorrect. And because Alma is written in R, one of the cool little things I did is I did a simulation and I asked it 100 times how many N's are in the word unconventional. And 14 times it said 1, 2, 76 times it said 2, and 10 times it said 3. And you'll notice it never once got the correct answer, which is 4. Now, if you look closely here, you might notice I'm cheating a little bit because I've deliberately specified this model, Claude 3.7 Sonnet. And if you look at that string of numbers there, you might recognize that this is a date. So I'm using a model as of February this year, which in like LLM terms is practically prehistoric. If I ask this again with today's model, or a more recent model at least, it gets it correct. And this is not because like LLMs have gotten more intelligent. It's because LLM providers have been embarrassed by people asking how many letters are in a word and then LLM getting it wrong and it looks bad. So now it's pretty clear LLM providers provide some extra advice whenever an LLM is trying to count the number of letters in a word. It now like spells out the word letter by letter and spends a little bit more time thinking about exactly how many N's there are. And this was pretty famously, there's a pretty famous controversy about this with ChatGPT-5 getting the number of B's in blueberry wrong. So LLMs kind of suck. The results are stochastic. The models are constantly changing. They're constantly moving the goalposts on us. I haven't really talked about this, but often sometimes you give it a question and it gives you a great answer. You give it a very small variation on that question, you get a terrible answer. But regardless, they almost always give you plausible answers, and they give you answers where the LLM never admits that it's like not at all confident about the answer. And they really admit doubt or lack of knowledge. So all of these things are true, and LLMs can do pretty cool things. Like you can now ask a computer to write a poem. Maybe this is not the best poem in the world, but a coder who worked with great zeal said tidyverse makes data feel real. With dplyr to wrangle and ggplot2's angle, my pipe dreams are now a good deal. Again, maybe not the best poem, but certainly a better limerick than I could come up with in 3 seconds. Or you can roast yourself. Another limerick form, making fun of how many packages the tidyverse loads. I forgot to include this in my slides, but other thing I did recently that went crazy on LinkedIn. Was the new Gen Z plier package, which converts dplyr verbs into Gen Z slang. So instead of filter, you can yeet your data. Instead of select, you can vibe check it. So I kind of accidentally created this package because I asked Claude to just give me some Gen Z slang for dplyr verbs. And then it wrote all the R code to do the translation. It generated a README, and it even generated a cheat sheet. So I felt obliged to turn this into a real package. And AI is getting pretty good at creating art as well, or at least graphics. maybe not the most amazing high quality high quality art you get from a real human being, but it's incredibly fast and incredibly cheap, and you can have a lot of fun brainstorming with it. And you can make fun games with it. So this is now starting to get vaguely related to data science. So let's jump over to my positron. And here, let me just switch my color theme to light. Make this a little bigger. You read that okay? So I'm just going to make, since we're here, I'm in South Africa. So please use, we'll see how this goes. So now I'm going to run this code. Okay, so you're going to have to translate for me. Okay, well, okay, I can guess this. What do I need to put here to sort by MPG? What's the correct answer? Anyone want to guess? Bit hard to see it all at once. A? Oh, we got it wrong. So the kind of fun thing about this is, like, first of all, I've created, like, you can kind of, I don't know, this is kind of fun. Maybe you could imagine using this in a class or to practice your own code. But the thing that's kind of fun about this is you can, like, kind of go off script, like, hey, I'm Hadley Wickham. I don't think any of those are correct. Okay. So let's hide this again. Or if you wanted to be a little bit more practical, I think one of the things that is particularly empowering about LLMs is they allow you to answer questions that you can't with search. Like, one of the things that Google has always been really good at is if you know the name of something, you can learn everything there is to know about that thing. But if you don't know the name of that thing, like, Googling isn't going to help you. And so here, like, I'm searching for the name of some R function I vaguely remember, and it tells me it's apropos. Like, this is starting to get kind of legitimately useful. I wanted to point out one other thing here, that I've supplied the first argument to Chat Claude here. This is what's called the system prompt. This is not something you'll be familiar with if you've just used ChatGPT or Claude on the web. This is a prompt that changes how all of the answers are going to be interpreted. So here I'm just saying be terse so that I get answers that fit nicely on one screen. But this is where you can say, hey, give me the answers in the language that I speak, or you prefer R instead of Python, or whatever other kind of context you want to use to shape the answers it provides. Well, this is a real thing that I did recently. I was working on a feature for Hitter 2, a web downloading package. And I was like, well, I'm working on this thing. I want to, like, throttle web requests, which basically means not running them so quickly so it doesn't overwhelm a server. Like, what should I think about? And this actually gave me something really useful. This gave me this idea that I needed to use a token bucket. I was like, well, I've never heard of a token bucket before. Like, did Claude just hallucinate this thing? But no, it's a real thing. I looked it up and I was like, oh, that's exactly the thing I need And that made solving the problem much, much easier because I now had the right kind of mental framework to solve the problem. So let's go back to the goals of this talk. I want to give you a few useful skills. I want to demystify a little bit of the jargon. And we're going to do that by looking at kind of 3 areas that I think are particularly useful for data scientists today. The first is structured data. The second is tool calling. And the third is coding. So let's dive in to structured data. So I want you to take a look at this list I've made in R. And I want you to think about, if you're going to write, what would you do if I asked you to write some code to extract the name and age of each person? So maybe just take a minute, talk this over with your neighbor. How would you tackle this problem? How would you get the name and the age? Any ideas? Like, if you're going to write a program to extract ages, say, what might you start with? Any ideas?
There's a reply online that says regex.
Right, you might start with a regular expression. And you might say, well, I'm going to extract the age, so give me all of the numeric digits that are in a row. That's going to work for this one and this one. Well, it's not going to pick up 19. Work for this one, and it's probably not going to work for this one because you don't normally expect a dash. What about extracting names? I mean, maybe you could come up with a regular expression that's like a word that starts with a capital letter that isn't at the start of a sentence, except that wouldn't work for this one. And then are you going to allow spaces or not? So this is the sort of problem that's like pretty easy for a human to go through, but really, really difficult to write a program to do this. But fortunately, this is something that LLMs are really, really good at. So I can start a chat instance. I can kind of give it a task. What I want you to do is I'm going to give you some text, and you're going to give me the name and the age. So I can say, give it the first one, it extracts Alex is 42, Jamal is 27, Li Wei is 19, so on. And this is pretty cool. This is just using text. It's, if you wanted to put this into a data frame, you have to do a little bit more work. Like, you're still going to have to write a regular expression to extract it out of this text, which is much simpler because it always has the same structure. But maybe we could do even better. Maybe, wouldn't it be nice if we could get like a list out of this? And in fact, we can by switching from chat to chat structured. So you're going to need, if you use chat structured, you need to do one more thing, and that is you need to supply a description of what you want the data to look like, the extracted data to look like. And you're going to do that using this thing called JSON schema. It's not super important exactly what that is, but you can kind of get the gist of it. I want a name that's a string and an age that's a number. And now I can extract data from each of these strings into a nicely formatted list. Or I could go one step further and I could use parallel chat structured. That's going to create a bunch of chats, run them all in parallel, do some magic to figure out, actually, in this case, it could give me a data frame back. And so now I think this is a really, really cool technique. Or we could use another tool called batch chat structured. This is going to take longer, but it costs half as much. And I really think this is kind of like a data science superpower, because it allows us to go from unstructured data, whether that's text or image or audio or video, and turn that into nice rectangular data frames. And now we can apply all of the tools we already know about to work with those rectangular data frames. And as I mentioned, this doesn't just work with text. So say you've got a bunch of images. You can also use images with Alma. I'm going to still do a little bit of functional programming magic to create a list that has this content image file. This is just a pointer to the image on disk. I'm going to say I want to extract the animal and the background color. I can again use parallel chat structured, pass it those images instead of those text. And now I'm going to get the type of animal and the background color. And I show you 4 results here, because again, if I repeat this 4 times, I get 4 slightly different answers. And I'm not going to make you spot the difference here. I'm going to highlight them. So for some of them, it says, for this picture, it says kitten, and some of them it says cat. And some of them it says the background color is gray, and some of them it says the background color is beige. And this feels like a different type of problem, right? Because if you asked 4 different humans what animal this is, some of them might say kitten and some of them might say cat. Some of them might say the background is gray or beige or tan or whatever. This is a problem of kind of lack of specification, lack of specificity in your question. But this is something that is really important to think about, that whenever you start programming with LLMs, you need to think about, well, like, are they doing a good job or not? And I don't have time to get into it here, but my colleague Simon at Posit has written this package called Vitals that basically brings some of the mindset of the tidy models group to evaluating LLMs. And I will say, like, one of the kind of interesting thing about LLMs is for like any kind of problem that involves an LLM, like the solution very often involves like another LLM. So one of the things that people often do when evaluating LLMs, because often LLMs are going to do complicated things to evaluate, like write a limerick or extract some text, you're going to use a different LLM to evaluate if that first LLM did a good job or not. That all sounds like a little bit like concerning. You're sort of building this like tower of what's on the foundations. But often, like for many problems, it's much easier to tell if you've correctly solved the problem or not than it is to actually solve the problem. And you can do various things by using one LLM to generate the solution and a different LLM to grade it to make sure that there are no kind of biases. But it ends up being it becomes a problem that statisticians already have a lot of experience with around like inter-rater reliability and how do you control for different sources of bias. Okay, so that was structured data. I think structured data, really cool, allows you to go from whatever unstructured data set you're dealing with to a nice rectangular, tidy data set that you've got tons of tools to deal with. The next thing I want to talk about is tool calling. And tool calling leads to agents, and both tool calling and agents are topics that there's a lot of jargon around, but hopefully, as you'll see, the underlying ideas are actually pretty simple. So the basic kind of problem that tool calling set out to solve was that LLMs don't have access to live data about the world. So if you ask Claude, what day is it today? It's going to say, sorry, I don't know. And that's actually a good answer, because if you ask ChatGPT the same question, it tells you it's June 17th, 2024, which is clearly incorrect. And LLMs also have no ability to make changes to the world. So maybe you want to delete all the CSV files in your current directory. Well, the best an LLM can do is to give you a little bash script that you could run on your command line. So tool calling is designed to solve both of these problems. And I think this tool calling is one of the reasons that people are kind of so excited about LLMs right now, because they give LLMs kind of the ability to like break out of their box and do non-LLM things as well. So what is a tool? Well, a tool is just a function along with some metadata. So I'm going to write a tool here. The tool is going to call the sys.date R function. That's just going to return today's date. And then I need to provide some metadata to the LLM so it knows how to call it or why to call it. What's its name? I'm going to call it today. What does it do? Not very complicated. It gets today's date. What arguments does it need? None. So that's all that a tool is. Now, once I register that tool, if I ask, well, either Claude or ChatGPT, what day is it today? It can now answer that question correctly. So how does this work? It would be a little bit surprising if like Claude had R installed, but it's not actually running the code on its computer, it's running the code on your computer. So what's happening, you, the data scientist, say, what day is it today? The LLM is going to be like, well, I don't know the answer to that. I need you to run this function for me. I need you to call this tool. So please call the today function and give me the answer back. And now the LLM can return the result. So this is really powerful because now you can give the LLM the ability to run code on your computer. Like very powerful, also very dangerous, obviously, but it's not just constrained to the data that it has available, but now you can connect to databases that your computer can connect that to, or read files from your local directory. So one way we can do this is to give an LLM kind of traditional computing powers. So I can give it a function to multiply two numbers together. And the function is probably more complicated than it needs to be because I needed to force it to give it the number as an integer, not in any kind of scientific representation. What does it do? It multiplies two numbers together. What are its inputs? Well, it needs a number passed to X and a number passed to Y. And now we can go back to that original problem that of LLMs can't multiply two numbers together. No, they can't, but they certainly know when to use a calculator. And now when we give it this calculator tool, it can correctly compute those answers. So this is kind of why, again, I think tool calling is so exciting because it kind of breaks LLMs out of their box. They can do the things that LLMs are good at, but they can also do the things that LLMs are not good at by just using a computer. And if you do this in, I think this is ChatGPT, very much the same thing happens. If you ask ChatGPT to multiply two numbers together, it knows it's not very good at multiplication. It's going to write some JavaScript code to do that multiplication and then give you the answer. So these tool calling capabilities are exactly what the providers are using to add extra functionality to the web interfaces that you are familiar with. So that leads me to agents. So if you've read anything about AI recently, you've probably heard about agents or agentic AI. And at least in my experience, you can read a lot about agents and still have zero clue about what they actually are. And it turns out, like if you know what a tool is, and a tool is just a function with some metadata, it's actually really easy to describe what an agent is. An agent is just a pair of tools. One tool that can kind of learn about the world in some way, and one tool that can change the world in some way. So let's make an agent in R. I'm going to give it a tool to list all the files in the current directory just by calling the dir function in R. And I'm going to give it a function to change the world in some way. In this case, I'm going to give the LLM the ability to delete files. And now I can say, hey, Claude, can you delete all the CSV files in the current directory? And it'll say, okay, well, I first need to find out what files are in the current directory. So it's going to use the ls, it's going to ask Alma to run the ls tool call. It's going to return the results. Then it's going to say, okay, well, there's two CSV files there. I'm going to delete them. I'm going to call that tool call. It works. And now it's done. I've deleted two files on my computer. And hopefully when you think about that, you are filled with horror. I've just given an LLM, which, as I've said, is notoriously unreliable, the ability to delete files off my computer. That is probably not a good idea. It's almost certainly not a good idea, but it does illustrate the power of agents. And to some extent, I think it illustrates kind of the current thinking about how you manage security of agents, which is, I don't know, hopefully it all just works out. So I think like tool calling and agents, clearly a huge amount of potential there. Still massive, massive questions about how can we do this safely and securely. Like my experience, at least, is allowing LLMs to do dangerous things is that they generally don't do dangerous things, and it's fine. But I still have like lots of backups of my computer just in case things go wrong. Okay, so we talked about structured data, the ability to extract rectangular data frames out of unstructured data. We've talked about tool calling, the ability for LLMs to do new things by calling functions that you write. And if you combine a pair of those functions, one that can read the state of the world, one that can change the state of the world, now you've got yourself an agent, basically. Those first two topics are really about controlling LLMs from R. To finish off, I wanted to change tack a little bit and talk about kind of the opposite direction, which is probably what many of you are using LLMs for today, which is using them to produce code, using them to write R code. And if you do this, it's just worth being clear about kind of the 4 ways you might do this today. The first one is you might just be copying and pasting into chatgpt.com or claude.ai. Copy your question in, it writes the code, you copy the code back into RStudio Positron and you run it. Perfectly fine way to do things, but it's a little bit clunky. You might also, in RStudio or Positron, might be using kind of autocomplete, where now instead of traditional autocomplete, which just gives you autocompletes the name of the function or the name of the argument, you might be using something that's AI powered and now gives you a few more suggestions. You might be using an in-IDE chat, which is basically just the web chat, but it's all inside your IDE, so no longer copying and pasting things back and forth. Or last and kind of the most recent fad is you might be doing some kind of agentic coding like Claude Code, where you're basically telling, well, actually, let's just show you a few of these. We'll have to hide this every time. Let's just take a look. So let's see if I can. So this is what I mean by AI-powered autocomplete. It kind of guesses from the context. Now I want to compute the mean of y, and then I want to compute the correlation. Well, then maybe that's not quite what I wanted to do, but if I say z, oh, okay, well, I guess wrong there. Wow, and now it's gone like, now it's decided to write something really complicated that is going to use OpenAI to compute the mean, which is a truly bizarre suggestion. So that's kind of the good and basically the good and bad of these AI-powered autocomplete. If you're doing like pretty routine boilerplate, it can be really helpful. It can just, it can kind of finish your thought if you're doing the same thing to a bunch of variables or the same basic transformation. And then it can sometimes go completely off track and just generate a function that you have never contemplated writing. And you're kind of distracted because you've now got to look at that and be like, is that what I want? And be like, no, and then cancel it and keep working. Okay, I'm just going to move this up here. Okay, so that's the autocomplete. We also have chat in the browser. So this is in the IDE. So you could say like, write a Shiny app that I don't know, shows how linear regression works. I have no idea what it's going to come up with, but it's going to churn away. It's going to write a bunch of R code. See it churning away. I mean, maybe on the whole, you may well be a better Shiny programmer than Claude, but it's unlikely that you are a faster programmer. So now I can like run this. Oh, I forgot to cancel the app I was running before. I can run this. And now get something, I don't know, let's. I don't know if this really shows you how linear regression works, but it gets you started very, very quickly. I'll kind of come back to this in a little bit because I think this is one of the areas in which LLMs excel, is like kind of cool demos and getting you started. But this is the chat. And then now the advantage of this, rather than copying and pasting back and forth between Claude or ChatGPT, is I can just run the R code immediately. And then the last type of thing is called agentic coding. So I use Claude Code in the terminal. And I guess we could do the same thing just to kind of see the difference. And so what being an agent means in this context, is that it's going to go and do a bunch of work. And the basic way it does this is it uses like reading and writing tools in a very similar way. Like one of the tools that Claude Code comes with is basically a to-do list. So the first thing it does is going to generate a to-do list, and it actually like writes that to disk, and it kind of like checks it off over time. Like that's, and you can kind of imagine, you could imagine writing the same thing with a tool call that would read the to-do list and a function that would check items off the to-do list. So this is how it kind of remembers what it's doing. And then Claude Code doesn't like run, I mean, it kind of can, but it doesn't write R code directly. It's not really gonna, it's really designed to like do stuff to your computer. This is kind of the other sense of agent, and it's just gonna go away, spend a bunch of time working, and I have no idea what it's done. And I've just done this in a random directory, so who knows? But it's created, and I could read it. Let's just switch its. Let's just follow its advice. So I'm going to switch back to R and say Shiny Run App. Actually, let's just pop it out into a browser so it's a little bit easier to see. And it's done a pretty similar thing. It's kind of harder to demonstrate kind of Claude Code live like this. It works, it's much more useful when you're in like a large directory of code. You can give it tasks to go and do, and it'll do its darndest to do those tasks. Sometimes it'll do a great job, and sometimes it'll do a terrible job. So what are some of the kind of clear wins for LLMs? I think the first place that LLMs are really good at is translations. Obviously, they're pretty good at translating between human languages, but they're also really good at translating between like various forms of computer expression, whether that's from JSON to a unit test, or from SQL to dplyr, or from SAS to R. Like if you can express what you want in some programming language or something programming language adjacent, And LLM's going to generally do a pretty good job of turning that into code for you. One particularly kind of cool thing, unfortunately, this is currently broken in Positron, but one cool thing that you can do is you can like sketch stuff out on paper, take a photo of it, and then say, hey, make a shiny app. So this is an idea from my colleague George. I'll just make this a little bigger so you can kind of contemplate this shiny app. Pretty quick sketch. Will be, let's see how it does. So still writing the code. Okay, actually, I don't want to do that. I just want to copy this, go back into Positron, paste it, close this shiny app, run this shiny app. Nope, that's still the old shiny app. Run this shiny app. Okay, open that on my browser again. And it's done like a pretty amazingly good job. Got a thing to pick variables, and I can pick different now, obviously, like part of the reason it's done so well here is it knows about the penguins data set in R. No, there's like enough examples that it knows to load the Palm and penguins data set. So it's kind of imputed like a lot of context that it knows about penguins data that it's not necessarily going to know about your data set. That's going to be something that you would have to give it a bit more context about, but still like a pretty amazingly fast way to get started with a shiny. And I think this is sort of another case, like another general set of tasks where LLMs do really well. I think it's kind of, I think of it as like lowering the activation energy. So makes it really, really quick to try out a new, maybe you've never used Shiny. Now you can just, in a couple of minutes, create a working prototype that you can experiment with. I find it pretty useful for writing, not because I like what it writes, but because I don't like what it writes. But reacting to something is much easier than like starting from scratch. It's like often much, much easier to change something when it's obviously wrong than it is to start from the beginning. This kind of reminds me of like in the old days, the R help mailing list used to be the place you'd go to get help about R. And I kind of discovered like sometimes, like if you asked a question, sometimes like people would just ignore it. But if you made a statement and that statement was incorrect, someone would feel compelled to correct you. It's kind of a high risk strategy, but if you really wanted an answer, you just say something incorrect. Recently, I've been working on the test that package. I used it on a few issues that have been sitting there for like, I don't know, there have been a couple that have been there for like 6 or 8 years. Basically, because every time I looked at them, I was like, oh, it's going to be a lot of work. Like, I'll just do it next time. And I kept doing that like for 6 years. And this time I was like, okay, well, you have a go Claude code. And sometimes it would just like fix the problem. I'd be like, oh, that was actually much easier than I thought it was. About half of those times I was then later, oh, actually it didn't fix the problem and it's not as easy as it thought it was. It's actually harder, but at least there was something there, even though it was wrong. And then I felt compelled to fix it. So it kind of got me over that hump of like, I'm going to start engaging with this problem, start tackling with this problem. Even though the results weren't perfect, it still got me started and got me going a little bit faster. Certainly now is a great time to, if you know one programming language, to learn a new programming language. I think the core skills of programming are still incredibly useful. And if you're familiar with R, asking an LLM to translate R code into another language, so helpful because you can learn to read that language pretty quickly. You can reason mostly about whether it's doing what you want or not, but it gets you over that initial kind of painful period where anytime you try to do something, you're like, oh, how do I write a for loop in Python? And it just makes it so hard to get up and running because every single thing is such high friction. Or in general, anything you've been putting off, like if you've been putting off writing tests for your package or documentation for your package, again, maybe it's not going to be perfect. Sometimes it's going to be great. Sometimes it's going to be terrible. But even when it's terrible, it really helps you get up to speed much faster. And I asked Claude to try and summarize this. So I thought it did a pretty good job of saying the LLMs make the cost of trying so low that you attempt things that you wouldn't have before because you would have put them off or never got around to it. Okay, so to sum up, I did want to talk a little bit. I've talked mostly about the things. I talked a little bit about the things that are bad that LLMs are good at, but I did want to talk about like some of the concerns that you might have. I think there's definitely a lot of concerns about the cost and the kind of equity of access to these things. I will say it's surprising if you want to use these tools, by and large, from R, you've got to put a little bit of money down. But like $5 US, a couple of $100 is going to get you quite far. Because many of these experiments are going to cost you like 3 cents or 1/10 of a cent to run. Certainly, as soon as you start writing for loops and you write like big prompts, you can burn through money very, very quickly, but you can also learn quite a lot for a very small amount of money. The other thing that makes life better generally is that there are really like what we call 3 frontier models or 3 companies that are kind of making the best models, and that is Claude, OpenAI, and Gemini. And they're kind of constantly in a race for like who's on top. Like Gemini 3 just got released, which is like better than Claude 5.1, which just got released. But don't worry, Claude 5. OpenAI 5.2 will be released soon, which is better. So they're kind of constantly battling for top spot. But Gemini is pretty clearly in 3rd place all of the time. And that is good because Google has bucket loads of money. And what they are going to do is they're going to spend that money to try and buy their way up into the top. And that means they have a very generous free tier. So if you want to get started and not pay any money, you can use Google Gemini and get a very long way for $0. Not going to work in the long run, but for now you can take advantage of it. It does kind of bring me to the next point, which is like environmental concerns. I think like absolutely, like I 100% like believe that you should care about the environment. Like global warming is real and everyone should be trying to, reduce their environmental impact. But at the same time, I think like likely that does not mean reducing the amount you use ChatGPT. Like probably the CO2 that I consumed flying to South Africa to visit you is like 100 years worth of ChatGPT usage for all of you put together. So there are many things that you should be worrying about, like before you worry about your use of LLMs. And I think we are finding that some of the kind of initial estimates of how much water and energy an LLM question uses were excessively pessimistic. The costs are going down. The model, there's a lot of pressure to do this efficiently and make money off of it. And that means, fortunately, kind of reducing the overall burden. So worth being a little bit worried about, but overall, I think if you're worried about the environment, there are better things you can do than reduce your LLM usage. Data privacy is another big issue. This is kind of interestingly mostly a concern for you as an individual or maybe you as a small business. This is not a concern for large businesses because by and large, like large businesses already have all of their data on the cloud. They already have their data in Amazon or Google or somewhere else. So, and the LLMs run inside those clouds. So if you work for a big organization, you mostly don't need to worry about this because someone in your enterprise, in your IT department has already negotiated with Claude or OpenAI or Gemini to be like, hey, don't capture any of our data. And because Google and OpenAI and Claude all really want the money from big organizations, they do a lot of work to make sure that happens. So this kind of data privacy tends to be an issue, like definitely should concern you as an individual researcher if you are dealing with, personal information about anyone. You should not be sending that data to LLMs. But by and large, you can figure out some way to create a summary of your data that doesn't contain any sensitive information, and then still give that to the LLM, and it can still help you write R code. And then the last one, I do think a real concern with LLMs today is evil billionaires. You, of course, have your own personal evil billionaire. South Africa. I am like half joking here, but I do worry that, like, I think one of the concerns with LLMs is just that they are concentrating wealth into the hands of a smaller number of people. I think there are some kind of like fantastic use cases for LLMs and an AI in terms of translating, in terms of transcribing, allowing people who are not literate to get access to information. I do think there's maybe a path where it becomes much more easy for individuals to start new companies, to brainstorm new ideas, because LLMs kind of give everyone that power to be like a semi-competent programmer, which is both tremendously scary and I think potentially tremendously enabling for the world. But realistically, I'd say the path we're on right now is there's going to be a handful of companies that control the most important LLMs that just make billions and billions of dollars and do all sorts of terrible things with that money. So on that note, I do strongly believe that like you can make a difference as an individual. Like I included this picture because like one of the things that I do when I feel kind of like sad or frustrated with the world is I go out and like pick up trash. And like, sure, it doesn't make the world that much better, but it does make it a little bit better. And there are still lots of things that we can do as individuals to make the world a better place. It's not your responsibility to do everything, but if everyone does like a little bit, we'll all get a little bit better. And if you are kind of like worried or fearful about LLMs, I think the best thing you can do is try and engage with them, try and find areas where they can like help you and others around you. So I showed you kind of 3 ways you might do this as a data scientist. You might use LLMs to extract structured data from unstructured data. You might start empowering LLMs with your R functions or creating little agents. And you might use LLMs to help you write better code. Thank you.
Thank you very much for a very interesting talk. There's already one question online, but maybe someone here who would like to ask a question. Hans Peter?
I realize it may be a really stupid question, but that's what questions are for. I've been using RLS to scrape data, and then I run into difficulties with that it seems to activate dynamic websites as difficult to reprogram them. Would these LLM models be a way to handle that problem?
So there are these things, I think it's called, there are these like various, I think Claude has one. There's these things called like computer use where basically people have trained LLMs to kind of like go to websites and click on buttons. They're not like that good and they're very expensive, but I do have an answer for you. There is another function in Harvest you can try, which is relatively new, called Read HTML Live. And that actually runs the web page in a real kind of off-screen browser on your computer. So if you can do it in the browser, you can like click buttons and type keys, and this will probably, this might help your, this might solve your problem.
Another question.
Someone that's starting with shiny apps, and how do I balance becoming lazy and using a lot of LLMs as well as being efficient in terms of this new world that we can do a lot with LLMs and also for code shiny apps?
Yeah, that's a good question. Like, you know, one of the things I did not mention that LLMs are good at is like kind of, they're really great at demos, but like as your Shiny app kind of grows over time and gets more complicated, LLMs will have a tendency to make kind of this nightmarish spaghetti code that you can't understand, that they can't understand, and kind of over time, your development velocity gets smaller and smaller and smaller. So like you can't use, I don't think you can use them to create like complex apps that you're developing over multiple months. So how do you make the most of like you as a human and like the LLM? And I think some of it is just like recognizing the kind of human tendency to be lazy and saying like, okay, well, I could just take the easy way out, but actually I'm going to read through the code that this LLM has generated, and I'm going to make sure I understand all of it or most of it. And if you don't understand it, then like ask the LLM to explain it. Or if you see like a bunch of code where you're like, wow, that seems really complicated, like try and simplify it yourself or ask the LLM to simplify it. So to me, it's like that engaging with the code, like iterating with it, like thinking about it. Don't just like take whatever the LLM gives you and go with that. Like that's going to get you a cool demo. That's going to get you quite a long way, but it's not going to like make you like a better programmer or, you know, a more useful data scientist. So I think that is it to me. I think the other thing that you will discover, like as you do more of this stuff with LLMs, is you'll often get into a point where you're just having this long conversation with an LLM and you cannot get it to understand exactly what you want. And it just keeps doing the wrong thing again and again and again. And often in that case, what you need to do is just like go into the code and fix it. Like you've hit a problem where maybe like English is not precise enough to describe exactly what you want to do. And at that point, if you know what the code does, it's really easy to go in and make the exact change you care about.
Okay, I like to read there's been some comments, but I like to read the question online. Have you tried or know someone who used DeepSeek running on their own hardware, maybe with a Loma? Would that work with LMR? Also, what about DataBot?
Yes, so you can use local models with Alma. So local models, like there's two things that are special about local models. The first of them is that they're open, so that the people publish all of the weights for the model. So you can download them and run them on your computer. There's like two problems with running models locally. First of all, you need like a pretty beefy computer to run it. It needs to have a good GPU, which most laptops don't. And if you want a laptop that does, you're going to spend several thousands, multiple thousands of US dollars on it. And then the second problem is, even if you do that, the local models are still going to be slow and like not particularly good. So you can use local models effectively, but when you're getting started, much easier to start with these hosted models. They're going to give you much higher quality results, much better performance. And like using open models on local models is just almost a completely new set of skills, because I think to get good performance from them, you really have to have narrowed it down to a specific task. And you have to do something called fine tuning, where you basically make some tweaks to the model parameters to make them particularly good at the task you're doing. So generally where I see people doing that, like in industry, is because they have found like a problem that an LLM does a really good job at solving, and now they want to make it faster and they want to make it cheaper. So instead of using a big, powerful off-the-shelf model, they take a smaller, simpler model, they fine tune it just to do that one task, and then they can make it pretty good at that task. But it's a lot of extra work, and for most people, that effort is not going to be worth the cost.
Okay, there's another one online. At the City of Cape Town, we have a couple of LLMs running on on-site servers for data privacy reasons, City GPT being chief among them. Is it possible to interface with these models using LLM?
Yes, so with Elma, I want to show you if I can remember what it is. Yeah, so the vast majority of models use this OpenAI compatible API. So this was the API that OpenAI, it's really hard to say, the API that OpenAI used to use and used to recommend. It kind of became a de facto standard. In fact, OpenAI no longer uses it. So in some sense, OpenAI is not OpenAI API compatible. But for the vast majority of cases, you can use this to talk to whatever model you're using, regardless of where it's hosted.
Okay, then a third one that came in just now, thinking of using LLM to do what you demonstrated with the names and ages, but with medical data captured only in PDFs. Lots of documents. What do you think about the feasibility?
Yeah, absolutely. Obviously, with medical data, you're going to need to be very careful about the privacy issues there. Certainly, there's things you can do with Claude or with any of the major providers to be able to use it. With medical data, you need to do that. But yeah, this is one of the things that LLMs are really good at. If you've got a bunch of PDFs, kind of, roughly the same, or if you could tell a human, hey, extract this data from the top left, it's normally under like date of birth or something similar. LLMs are like amazingly good at doing that. They're still, and they're getting like better and better at handwriting. So I think you can kind of get like specialized models that are really good at handwriting, but Gemini, Claude, OpenAI, they are going to do a pretty good job of transcribing handwriting. Gemini, in fact, I don't know if I still have it up, but recipes. I don't know if I can find it, but the Gemini 3. Maybe it was no. They released this like 2 days ago, but they have a really cool demo, and I'm sure it's like slightly faked and very best case scenario. But if someone just taking, their messy scrapbook of recipes from their family, just taking photos of them all, uploading them to Gemini, getting it to transcribe it, then they were all written in Korean, so also produce an English translation and then make a website out of that. Like that's something that LLMs are just really good at. Still want to go through it like as a human. There's still going to be errors, but order of magnitude faster than doing all of that by hand.
There's one more here, but is there any more questions from the in-person audience? Yeah.
I've always liked Shiny, but I find it so difficult to program. And I think LLMs are the way to go. So thank you for that. That's very good. It sounds like I could just come up with any ideas, sketch it on a percentage into another.
Yep.
And the Shiny.
Yeah. Yeah. And because you might not know Shiny, but R code, you've got like a decent chance that you could still be able to go in and edit it yourself, make changes to the kind of non-Shiny bits, debug it when it goes wrong. Yeah, I think that's a super.
Stefan?
Just a very curious question. I found, generally speaking, when someone's a user, that they use Windows, but I've noticed that you're a Mac user. Is there a particular reason why you use Mac?
So the weird thing is I'd say 80% of our users use Windows, but I don't know, 80% of people who develop R packages use Macs. So if you go to an R conference, most people present from a Mac. And I think, yeah, everyone on my team uses Macs. Some people will spend some of their time in Linux. Some people will force themselves to use Windows to make sure things work on Windows, but generally hate it. But yeah, like everyone I know uses a Mac basically.
Yeah.
So yeah.
Okay, the question online was, is the old OpenAI compatible API usable for Copilot?
That is a complicated question to ask because Microsoft has started using Copilot to mean like 15 different things. So yes and no. If you, yeah, I think that would be like too much to get into here. But if there's also, if you're using it through GitHub, there is a chat GitHub that works with the GitHub Models Marketplace, which I don't think is branded Copilot, but everything else seems to be. So you should, if it's something like LLM-like and Elma doesn't support it, like file an issue and I'll take a look at it. But no one has complained about not being able to use Copilot models, so probably can some way or another.
Okay, yes.
I wanted to ask about data analysis, and if, I don't know, in your work, if you're mostly doing package development or if you're also working with large sets of data, and how you would think this is going to change. I mean, using Elma data analysis, how that's going to involve and change. If it's something you should be using at the start of your data analysis, or should you be sitting and thinking, how do I want to analyze this data? What does it look like? A distribution of that. At what point are you bringing it in?
Yeah, I'm a caveat with like I do mostly do programming and not data analysis these days, but I think most of the lessons apply. Like I think you can bring it in multiple phases. Like in the early phase, you know, it's useful just to have as like someone as like a ChatGPT or Claude as someone just to bounce ideas off and like brainstorm like how might I analyze this? I wouldn't like, and you're going to use it like as you go through to like, you know, help you write R code. You can use it to try and like interpret plots. I think it starts to get much rockier there. It starts to get, it can, like we are I don't know how much of, if we have anything public yet, but we are working on this tool called DataBot, which is kind of where I don't think we have any answers, but we have some kind of thoughts about how this might look in the long run. Where DataBot kind of does more of that kind of analysis loop, but it always stops to like check in with you. And I think again, the challenge is like just not being lazy. Like it can do all this stuff for you so easily, but you still have to like do the hard, like it's data analysis is hard work. Like you've got to like strain your brain doing this stuff. And it's very easy to kind of like opt out of that. So I think like using it as a partner, using it to help you code, help brainstorm, let it loose on some of the analysis that maybe you thought was too hard or too boring, see what it comes up with, but still ask the same questions in other ways. The other thing that this is a team working on DataBot has discovered, and they've come up with this thing called Bluff Bench, is that they've discovered if you ask an LLM to interpret a plot, it often just interprets actually look at the data. So particularly if there's like a strong known relationship, it's not loading, but if you Google, you just Google Bluff Bench. Oh, okay, now it did. Like this is a plot of miles per gallon versus horsepower, but it's been flipped. So because normally you'd think the more horsepower, that should be a negative correlation, but it's a positive correlation here. And if you ask basically any of the modern LLMs to say, is it a positive or negative correlation? it tells you it's a negative correlation because it's not actually looking at the points, it's looking at its preconceived notions. So I think there's a lot of promise there to help interpret plots. I think there's a lot of promise, like particularly if you're in a field that has a lot of like structure around how you report your statistical results, of having like LLMs like write all that standard verbiage. But I think, I don't know, again, I think my general advice is like, look for parts of your job that you don't like and see if you can like pass those over to an LLM, you know, being skeptical of it's good or not. Try and keep the stuff that you love. Like, you don't need to stop doing that. Like, do the stuff that you enjoy and you love.
Okay, so
What
Yeah.
do you think of DuckDuckGo?
I actually, I don't actually use Duck. I actually use Kagi now. Okay, I don't know how you pronounce it, which is better than DuckDuckGo. I've given up on Google because it's just so, I hate all of the AI powered stuff in Google because it gives such terrible answers. And like so many of the first links are now ads. So I switched to DuckDuckGo for a while. I found it better, but I like Kagi even better. It's unusual and it's a search engine you have to pay for each month. But I find it gives better results. And one of the things that I like is it downweights in its search, it downweights like pages that have tons of ads on them, which often tend to be kind of the lower quality pages. So I like them as a company. I find it pretty good. The main thing that's annoying, despite all of the EU antitrust regulation, you can't easily change like the default search engine to use it. So there's all these sort of hacks to get around that, which is why you see DuckDuckGo briefly.
Okay, well, I think we can thank Hadley for a very interesting talk and for answering all the questions with so much detail.
Yeah.
And then we'd like to invite you for something to eat and drink.